Hey you guys, welcome to one more video. Today we will test a new 3D printer, so stay tuned. Hi guys, welcome back! But before we start with the unboxing, don't forget to subscribe our channel and give us a like. This time we have the Ortur 4. This model started with the version V0 that was later upgraded to the V1 and the V2. In this video, we will test and review the V1. And now Rui will guide you through the rest of the video.
Hi guys! So, inside the package and at the top, we can find a bag with several things and which we will see in just a minute. A small sample of PLA filament and a spool of white PLA filament. The power cord and the cutter. Next, we have the spool holder. And the top horizontal bar. Next, we have the back structure of the X gantry, and the rest of the X gantry. And this is the bottom half of the printer. Under it, we can find a couple of profiles. These are the vertical ones. And a couple of lead screws. Inside the bag, we have a couple of wooden blocks, a bag with tools, the memory card reader and the memory card, a small plastic piece, a spare PTFE tube, and finally the instructions. The main X gantry piece includes the X-axis stepper motor and the print head. The PTFE tube comes already inserted in the hot end. The print head includes an auto level sensor at the left and a layer cooling fan duct at the right. There are also a couple of cable tracks for the X and Z axis. At the back side, we can see the rollers. Each axis profile will have 3 rollers running inside. All of them come pre-greased. On the back X gantry structure, we have a couple of lead screw nuts, the extruder, and filament runout sensor. The extruder is single geared but all metal. The top horizontal bar has a couple of printed pieces. Here is where the top of the lead screws will be. And these are the vertical profiles. They are equipped with small but long rods inside, allowing rollers to run smooth inside them. And they also come pre-greased. And this is the bottom half of the printer. At the left, we have the USB connection, memory card slot, and 3 connectors to connect all the wires from the top half. At the front, we have the graphics display, the control knob, and the reset button. The heat bed is made from aluminum and has a glossy sticker on top. At the right side, we have an opening for the input voltage selector. This selector must be checked before the first power on, And our machine is correctly set for our main voltage, but we noticed lots of solder on it. At the back, we have the power cord connector equipped with the main fuse and the on and off switch. And these are all the things that came inside the package. To access the electronics, we need to remove all the screws from the bottom, including the ones inside the feet. Inside, we have a simple setup. Right off the bat, we see a big cooling fan covering the entire main board. Under the fan, we have a small board with the label Ortur4 V1. The board is clean and simple. It's equipped with an 8-bit Atmega 2560 microcontroller and 5 non-replaceable Allegros 4988 drivers. The power supply is a big 24 volts and 50 amp model with self-cooling, and at the side we have a small interconnect board. Now for the assembly. We start with the vertical profiles. At the sides we have openings for the beams. Before inserting them, check for wires and move them away. The manufacturer must reconsider the way how they secure the wires inside to prevent them to be crushed by the profiles. The profile with the 2 extra holes is installed at the left and with the side holes facing out. The second profile is also installed with the side holes facing out. To secure the vertical profiles, a couple of M4x6 screws are used on each side. During the assembly, check the entire machine for loosened screws and tighten them. Now, the X gantry. At the back side, we have 4 points to secure the back structure. Take 4 M4x10 screws and use them to secure the back structure. Make sure you secure the structure parallel with the X gantry. Now we can slide the X gantry down the vertical profiles. Use the longer track between the print head and the heat bed to avoid scratching the bed surface with the nozzle. The end of the longer track must be placed between the left vertical profile and the X-axis stepper motor. In the meantime, use the top horizontal bar to protect the bed surface. There are 3 holes, but only the middle one will be used to secure it, and with the small M3x6 Phillips screw. Next, using a couple of M2x8 screws, secure the Z end stop. Now we can install both lead screws. Tighten the coupling set screw. Confirm if your lead screw nuts are tightened. If not, tighten them. Now we can raise the X gantry by rotating both couplings. Connect the filament runout sensor and the extruder stepper motor. At the side, connect the 3 cables. The 3 connectors have different pin counts, so there is no way to connect them wrong. The plastic piece is to cover the connectors. Next is the PTFE tube that needs to be secured to the extruder. Now get a couple of M5x40 screws. The top horizontal bar is placed with the printed parts openings facing down to the lead screws. Insert the screws, but don't tighten them just yet. Get a square and measure the distance between both vertical beams at the top and at the bottom, and then tighten the screws, maintaining the squareness of the frame. Finally, the spool holder and a couple of M4x6 screws. Install the spool holder facing the back side. One thing we notice is the alignment of the filament runout sensor with the extruder. The sensor is not aligned, so we had to tighten the sensor screws to move the sensor closer to the frame. With the sensor aligned, the filament will be too close and will touch the greased lead screw. Testing with a bit of filament, we can see that the sensor is too low and should be installed a bit higher. Inspecting the machine before the first power on is always a good practice, and while doing that, we found a disconnected cable, probably during transportation. To adjust the belt tension, the printer has a belt tensioner for the Y-axis belt. For the X-axis belt, there is no belt tensioner, but it's easy to adjust. One good point is that all idlers have teeth. And the printer is now ready for the first power on. We can now connect the power cord and turn on the printer. The manufacturer states that the printer has Marlin 2.0 installed. The menu options are the usual ones. We have the motion menu where we can move all the axes, home the axis, and there is a bed leveling menu where we can run the auto level sequence, adjust the probe Z offset, and store the settings to the EEPROM. In the temperature menu, we can control the heat bed and nozzle temperatures and run a preheat for each or both. In the configuration, we can turn on and off the runout sensor and the power resume. In the advanced settings, we can adjust many settings such as home offsets, acceleration, jerk, and so on. Included are a couple of wooden blocks. These are very handy and we rarely find such tools. These are used to level the X gantry, and the way it works is very simple. We place them one on each side against the vertical beams. Next, we lower the X gantry by rotating the couplings by hand. Since the blocks have the same height, the X gantry will be leveled when both sides touch the blocks. In our case, the left side didn't, And to make it touch, we have to force it, which is not a good idea. Although we have the correct distance between the vertical profiles, clearly something is not squared with the frame. Since the difference is not that big and to square this up would take a lot of work, we decided to accept a small deviation and proceed with the next step. We can use the menus to move the Z up a bit to remove the blocks. And now we can run the home sequence. This printer is equipped with both a mechanical Z end stop located at the back and with a printed piece to adjust the detection height and the auto level sensor, and we can choose to work with either one. You should start by adjust the leveling of the bed, so heat up the bed up to between 50 or 60 degrees. Use a 0.1 mm thick piece of paper, move the nozzle to the corners and adjust the height using the thumb nut under the bed. Repeat as many times as needed on each corner until the leveling is stable. And then confirm the center. In our case, the center was too far from the nozzle. Using a ruler, we can see that the bed is heavily warped. The good thing is that the printer is also equipped with an auto level sensor and therefore will compensate this warpage. The manual explains in detail how to calibrate the Z offset value. With the X gantry a few millimeters up, move the print head so the sensor is over the bed. Turn off the soft end stops and lower the Z in 0.1 mm steps. Stop when the sensor LED lights up and take note of the Z height. Continue to lower the Z until the nozzle touches the bed. Take note of this Z height as well. The math is simple. Take the Z height value of when the nozzle touches the bed, subtract the Z height value of when the LED lights up, add 0.1 and the result is your Z offset value. The value is entered in the Probe Z offset menu, the soft end stops should be turned back on and the changes should be stored right after. The auto level sensor probes the bed in a 5x5 matrix sequence. For the first tests, we used the PLA spool that came with the printer. In the memory card there are a few already sliced models and we chose one to start with. During our first print test, we found that the math didn't work, and we had to use the baby steps feature to correct the Z offset. Adjusting the offset live means that we don't need to stop the print. Before the second print, we ran the auto level again, but the auto level sequence failed and the nozzle hit the bed. And we got the probe error on the display. The printer only stops with the probing error when selecting level bed from the menu. If the probe fails during the G29 command, the printer interrupts the bed leveling and proceeds with the print. We troubleshoot the sensor using an Allen key and it was detecting, so we opened the print head cover and lowered the sensor and calibrated the Z offset value again using the math. While running another print, the auto leveling failed again and scratched the bed in the process. The live baby steps adjustment were not fast enough to save the bed surface. With the sensor randomly working, we abandoned the auto level feature and decided to use the mechanical end stop instead. The layer cooling fan and fan duct are located at the right side. We tested the print resume and it worked as expected. We also tested the pause feature, but it's not working as we would like. When pressing pause, the hot end is raised, moves to the corner, and then back over to the print leaking filament through the nozzle. The ideal would be to keep the print head at the corner until the resume button is pressed. Next, we tested the print quality with the traditional Benchy. The spool holder is too small for most of the spools in the market. This V1 spool holder design should be redesigned to allow bigger spools. The print head cover has an opening in the front of the nozzle for a better view of the print, and this is a good idea. Cable tracks are always a good choice to keep the cables organized and safe. In the memory card there is also a simplified 3D profile, but we didn't like the results, so we made our own simplified 3D profile which produces much better results. The print surface works pretty well and the parts do get stuck on it, and when it cools down we can take the print out without the need of a spatula. The only issue is that the manufacturer states that this print surface is only suitable for PLA. The print volume of this printer is 260 by 310 by 305 millimeters. And these are the print results. First is this model that was already sliced in the memory card. The model turned out pretty good. The layers are smooth except for the salmon skin, which is very noticeable. One thing that stands out is the bottom of the model. All this recess here was done with no supports and does not look bad at all. Next is the ripple cube that we use to start dialing our own profile. The faces of the cube look well made and the ripple is minimum. We then printed the Benchy, and in it we can clearly see the salmon skin on the cabin walls. Other than that is perfectly fine, except for some retraction issues that are related with our profile and not with the printer. Next was the Scooby model. Again, we see very smooth layers, only the salmon skin is messing what it could be a perfect print. All these prints were done with PLA filament. And finally, this vase printed in vase mode. Once more, we see awesome layers. And that's it, you guys. Hope you liked the video. Don't forget to give us a like and subscribe to the channel. As always, you can follow us here on YouTube, Instagram, Facebook, and Twitter. We will see you guys in the next video. Stay safe, guys.